Module 8, Chapter 5.3, Logarithms and Their Properties. A logarithm is an exponent, and log of x base a is the exponent to which a must be raised in order to obtain x. The number a is called the base of the logarithm, and x is called the argument of the expression log of x base a. The value of x will always be positive. For all positive numbers a, where a is not equal to 1, a to the power of y equals x is equivalent to y equals the log of x base a. Just remember, the log is always the power. To compare some different forms, in exponential form we know that 2 to the third is equal to 8. In logarithmic form, we say the log of 8 base 2 equals 3. Notice 3 is the power to which we raise the base of 2 to get 8. Same thing, 1/2 to the negative fourth power equals 6. In log form is the log of 16 base 1/2. You notice that the base was 1/2 equals negative 4 because negative 4 is the power that we were raising 1/2 to. 5 to the 1 equals 5 just means the log of 5 base 5 is equal to 1. And 3/4 to the 0 power equals 1. That means the log of 1 base 3/4 is equal to 0. Okay, let's solve by rewriting in exponential form. Well, the log of x base 4 equals 3/2 means the base is 4, the power is 3/2, and that is equal to x. Well, 4 to the 3/2 power means the square root of 4 cubed is equal to x. Well, the square root of 4 is 2, so 2 cubed is x, which means that x is 8. X equals the log of 4 base 8. Well, the log is the power, the base is 8, so that means 8 to the x power is equal to 4. Now what we're doing is we're looking at these going, well, we know that we can write 4 and 8 as a power of 2. So 8 would be 2 to the third to the x. 4 would be 2 squared. So like we did earlier, we've got 2 to the 3x is equal to 2 to the second. Since the bases are the same, we know that the exponents have to be the same. So 3x has to be equal to 2, which means x would have to be equal to 2/3. The log of 16 base x is equal to 4. Well, now this time we don't know the base. We know that the power is 4, and that has to give us 16. Well, the fourth root of x to the fourth is x. The fourth root of 16 is 2. So we get an answer of 2. Now, the two most important bases for logarithms are 10 and e. If the base is 10, we do not have to write it. That is, for all positive numbers x, the log of x is the same thing as the log of x base 10. If the base is e, we use the notation ln x, or natural log of x. And this is most common when involving growth or decay. And remember, the argument of any log must be a positive number. For all positive numbers x, remember the log of x is the same as the log of x base 10. So the log of 12 means find the power that we raise 10 to get 12. Well, there's no way to do these pencil paper, So we're going to pull up our calculator. So to find the logarithm of 12, you do the log of 12, which gives us 1.079. Now the log of 0.1, we can just go ahead and do that one on our calculator. The log of 0.1 would give us -1. And the log of 3/5, the log of 3 divided by 5, is -0.2218. Talk about the natural logarithm of base e. Like we said earlier, for all positive numbers x, ln x, or the natural log of x, is the same as the log of x base e. So evaluate the following, round to the nearest thousandth when necessary. Well, the natural log of 8, we're going to come down here to natural log of 8, and we get 2.079 rounded to the nearest thousandth would leave the 9. The natural log of 1, now if you want to go back and put this in our other terms, this means the natural log of 1 is equal to x, which means e to the power of x is 1. Well, anything to the 0 power is 1, so x would be 0. If we would do the natural log of 1, which is 0. Now think about this one for a second. The natural log of e to the 4th. This means find the power that we're raising base e to get e to the 4th. Well, that means x has to be 4, or if we did it on our calculator, the natural log, e is over here above this division symbol, so we say second e to the power of 4, which would give us 4. Okay, and then the last one, the natural log of the square root of e. Well, remember that the square root of e is like saying e to the 1/2. The natural log of e means find the power that we're raising e to get 1/2. So that means x would just be 1/2. You could still do it on your calculator. The natural log of the square root of the second e is equal to 0.5. Now for applications, the formula for finding the amount of interest when compounded continuously was A equals PE to the RT, where P was the amount of principal, R is the rate of interest, and T is the time in years. Now, suppose that $1,000 is invested at 3% annual interest compounded continuously. How long will it take for the amount to grow to $1,500? Well, if we go back and say A equals PE to the RT, let's plug in what we know. We want our amount to be $1,500. We know our original principal was $1,000. E, we know our rate is 0.03, but we're looking for T. So to solve this one pencil paper method, we're going to divide both sides by 1,000 because we want to get T by itself. So that would be 1.5 equals e to the 0.03 times t. Well, this is a log form because the base is e. So what that says is the natural log of 1.5 is equal to the power of 0.03 t. So we're going to divide both sides by 0.03. That says t is equal to the natural log of 1.5 divided by 0.03. So on our calculator, we're going to do the natural log of 1.5 equals divided by 0.03, which would give us a time of 13.5, or about 13.5 years. Now, for a couple of properties of logarithms. For a is greater than 0 and a not equal to 1, and any real number k, the log of 1 base a is equal to 0. Think about this. A, whatever the base is, to the 0 power will always equal 1. The log of a to the k base a is equal to k. Think about this. The base is a, the power is k, which will always give us a to the k. And then the third one, a to the log of k base a is equal to k. In the log form, the base is a, so we've got the log base a. The k is the argument, and the power is the log of that, which says that those two are exactly the same. So what we think about is the a base and the log cancel each other out. For x greater than 0, y greater than 0, a greater than 0, and a not equal to 1, and any real number r, the product rule for logarithm says the log of xy base a is equal to the log of x base a plus the log of y base a. The quotient rule says the log of xy is equal to the log of x minus the log of y. Notice the bases will stay the same for all of these. And then the power rule says the log of x to the r is equal to r times the log of x. So if we're doing the log of a product, we can separate them with a plus. If we're doing the log of a fraction, then we can separate them by the minus. If we're doing the log of the power, then the r comes around out front and multiplies by the log. So let's use these properties and rewrite each expression. The log of 8x is equal to the log of 8 plus the log of x. The log of a product is equal to the sum of the logs. Now the second one, the log of 15 over 7 base 9, well that's the log of 15 base 9 minus the log of 7 base 9. The log of the square root of 8 to the 5th power, we're going to have to redo that one a little bit. The square root of 8 is the same as 8 to the 1/2 power. Now we've got the log of a power, so the 1/2 comes out front. Then we get the log of 8 base 5. Let's do a couple more. Rewrite each expression using the properties of logs. Well, the log of 0.1, well, that is the log of 1/10, which means that is the log of 1 minus the log of 10. The log of x over yz base a, well, the first thing we're going to do is the division. So we've got the log of x minus the log of yz. Then we're going to work on the log of yz. So we get the log, these are all base a's, of x minus, in parentheses, is the log of y times, plus the log of z. And then if we distribute the minus sign, we get the log of x minus the log of y minus the log of z. And then the last one, the log base b of the third root of m squared. Well, we can rewrite that as m to the 2/3. So the 2/3 power comes out front, so it's 2/3 times the log base b of m. Now, assume all variables are positive. Remember, the argument can't be negative, so we're just assuming that all variables are positive numbers. Use the properties of logs to rewrite this. Well, first thing is, can we get it as a power? So that would be x to the 3rd, y to the 5th, over z to the m, and all of that is to the 1 over n. Okay, so we've got 1 over n times the log of x to the third, y to the fifth, over z to the m, which would be 1 over n. I'm just going to leave that 1 over n out front for a minute. The log, these are all base b, of x to the third, y to the fifth, minus the log base b of z to the m. Now, separating our product would be 1 over n times the log base b of x to the third plus the log base b of y to the fifth minus the log base b of z to the m. Now, one more, or a couple more steps actually. Let's leave the 1 over n out front. The log of x to the third is 3 times the log of x base b. The log of y to the fifth is 5 times the log of y base b. Minus the log of z to the m is m times the log of z base b. And now if we go back and multiply all those by 1 over n, we get 3 over n times the log of x base b plus 5 over n times the log of y base b minus m over n times the log of z base b. And that's what we say when we actually call this expanding the log using properties. Okay, now let's go the other way. Use the property of logs to write the expression as a single log with a coefficient of 1. Okay, so first thing we're going to do is take all the coefficients out front and bring them around. So we've got the log of m to the 1/2 plus the log of 2n to the 3 over 2 and the log of m squared over n. So this one, because this is a plus, that means those were multiplied. So we've got the log of base b of m to the 1/2 times 2n to the 3/2. The minus means we're going to divide by m squared over n. A bit, we would get the log of m to the 1/2. Now 2n to the 3/2 means 2 to the 3/2 n to the 3/2 over m squared n, which would give us the log of the square root of m 8, because 2 to the third is 8. Then we've got an n to the third over m squared n. Now, we know that the square root of n to the third means an n comes out and an n stays in. So this n out front could cancel with this n on the bottom. So what we get is the log base b of the square root of 8mn divided by m squared. That's how we would write that as a single log. Now let's do another one. The log of x plus 2 base 3 plus the log of x base 3 minus the log of 2 base 3. Well, up here, this is going to be the log base 3. Now this plus means we're going to multiply x plus 2 times x. The minus means we're going to divide by 2, so we would get the log of x squared plus 2x divided by 2, and that is base 3. How can we use our calculator to find the logs of bases other than 10 or e? You know, if we wanted to find the log of 6 on our calculator, then we just punch it in because we assume that that is base 10. But if we were trying to find the log of 10 base 6, how would we do it? Well, there's a change of base rule that shows us how. Okay, let's say it again. for any positive real numbers x, a, and b, where a is not equal to 1 and b is not equal to 1, then the log of x base a is the log of x base b over the log of a base b, which simplifies to say the log of x divided by the log of a, or the natural log of x divided by the natural log of a. For example, evaluate each expression and round to 4 decimal places. The log of 12 base 5 is the log of 12 divided by the log of 5, which would give us 1.543959. Now, if we round to 4 decimal places, that's going to be 1.5440. The log of 7 base 1/3. The log of 7 divided by the log of 1/3, which would give us negative 1.7712. And then the third one, the log of 0.1 base 2 is the log of 0.1 divided by the log of 2, which would give us negative 3.3219. And you're going to use that a lot, so make sure you remember that formula. Now you're ready to complete this section of homework on MyMathLab.